So we're going to take a look at the definition of a vertical asymptote. The vertical line x equals a is a vertical asymptote of the graph of the function f of x if one of the following statements is true. The limit as x approaches a from the right of f of x equals infinity. The limit as x approaches a from the right of f of x equals negative infinity. The limit as x approaches a from the left of f of x is infinity, or the limit as x approaches a from the left of f of x equals negative infinity. So we have a function here, f of x equals 1 over x minus 2. And you may have learned in your previous math courses that there would be an asymptote at x equals 2. Well, we're going to use this definition to prove that that asymptote does in fact exist. And while there are 4 different ways we could show that, let's go ahead and investigate what happens with the limit as x approaches 2 from the left of f of x. So we're going to choose values to the left of 2 on the number line, and we want them to increase and get closer and closer and closer to 2, so that we can watch what happens to those function values as I get closer and closer to 2 from the left side of 2 on the x-axis. So we'll choose x values like 1, 1.5, 1.9, 1.99, 1.999, 0.9999. So you should be getting a sense of what we're trying to accomplish here. So what are my function values? Well, for this first x value, I have 1 over the quantity 1 minus 2, which is equal to negative 1. And then we go down to our next value, 1.5, and that would be 1 over 1.5 minus 2, which is 1 over negative 1/2, which is negative 2. So I'm going to write these over here. So we've got negative 1, negative 2, 1 over 1.9 minus 2, quantity 2, and that is equal to 1 over negative 1/10. 1 over negative 1/10 will give us negative 10. So we've got negative 10. So notice as we're getting closer and closer to 2, we've gone from 1 to negative 1, negative 2, negative 10. Continuing, we will get 1 over 1.99 minus 2. So that's 1 over a negative 100. So that'll be negative 100. Then we have 1 over 1.999. That quantity minus 2 equals negative 1,000. And then for 1 over quantity 1.999 minus, I'm missing a 9 there, 2 is 1 over negative 10,000. So this would be negative 10,000. And we see a pattern emerging. We see that as our values of x approach 2 from the left, that the function values are growing very small. They're headed towards negative infinity. So we could take a look at the graph of this function, of 1 over x minus 2. And looking at the graph here, we can see that there is a vertical asymptote. And so the points we've been identifying on this function started here at an x value of 1, and as we got closer and closer to 2, we moved further and further down this piece of the graph that's headed towards negative infinity. So while we can use a table to demonstrate the presence of a vertical asymptote, we can also use graphs to help us determine the location of vertical asymptotes as well. So we have a function here, f of x equals the quantity x squared minus 4x plus 4 over the quantity x squared minus 5x plus 6. Now, if we were to use the simple rule that the values of x that cause the denominator to equal 0 are locations of vertical asymptotes, we would run into some difficulty here with this particular function. As we look at the graph of the function, we can see that there does appear to be one asymptote at, it looks like x equals 3. But let's take a moment to look at the zeros of this function. So if I were to take my denominator and to factor it, the factors of my denominator are x minus 3 and x minus 2. And notice there are two values of x that would cause this denominator to equal 0, but from the graph, we can see that there is only one asymptote. So let's look a little further to see what's going on. Let's go ahead and factor this numerator. So my numerator factors to be x minus 2 times x minus 2. And so we can see that we have this common factor of x minus 2. So we're going to allow those to divide out. And so we end up with x minus 2 over x minus 3. Now there is a caveat. We can use this simpler form of the function provided we do not allow x to equal 2. We've removed information from the original function. In the original function, I could not let x equal 2. Therefore, in this simplified form, I also must not let x equals 2. So what's going on here? Well, you can't really see it. There's a hole in the graph right there at x equals 2. Okay, so we do have a vertical asymptote. So vertical asymptote, I'm going to abbreviate VA, is x equals 3. We have to justify that. So that is because the limit, and I only have to provide one of these limits. Let's see, as x approaches 3 from above, from the right, of f of x. So coming from the right, my function values head to positive infinity. At x equals 2, however, we have a limit x equals, as x approaches 2, and actually as I approach 2 from both sides, that limit is 0. And this is because there was a hole in the graph. I hope this helps.